Hi students, welcome to Max Point of View. Today we are going to solve each and every numerical from the chapter Reflection of Sound and Echoes. This is part A of main chapter Sound. So here we are going to solve each and every numericals. Before this one we have understood the concept video. After that theory solution. If you have seen those two videos, this will definitely help you, or else few numericals will definitely confuse you. So my suggestion is watch those two videos first and come back to this video. All the videos, okay, whatever the videos I have mentioned, all those videos and the remaining the videos of all the chapters are available in the description box. So from any video to any video we can jump anytime. Just go to the description box, you will understand everything. So without wasting any time, we'll start with our first question. Our first question, a wavelength of wave produced on a surface of water is 20 centimeter. So first we'll write down the data. Wavelength, this is the symbol of wavelength. So this is 20 centimeter, and if the wave velocity is 24 meter per second, that is nothing but velocity, that is 24 meter per second, and calculate the number of waves produced in 1 second. So what you mean by number of waves produced in 1 second? Number of, that is nothing but number of vibration in 1 second. So what is this explanation? This is nothing but the definition of frequency. So we need to find the frequency. This is why concept video is important. Then the time taken in which one wave is produced. So we need to find the time also. Okay, now listen. So using wavelength, velocity, we can say find frequency because we have a formula, correct? But if you substitute these values, you will get the answer. Do you think that will be correct? No. Why? Because we own not only the given data, we have to see whether they are in their SI units or not. Okay, what is the unit of velocity? Meter per second. SI unit is perfect, that is meter per second. But what about wavelength? What is the SI unit of wavelength? Meters, correct? But the answer is in centimeters. So we have to convert into meters, then you have to substitute in the formula. So this is nothing but you can write it as 0.2 meters, or you can write it as like this. Okay, so the same thing we can substitute in the values, so that a few values will get cancelled instead of getting a decimal directly. Now what is the formula? Frequency is equal to velocity by wavelength. So now substitute the values. What is velocity? That is 24 divided by what is wavelength? Wavelength is nothing but 20 by 100. So 20 by 100. Now we can write this as 24 into 100 by 20, correct? So these kind of conversion you should know, because this is what we are learning from grade 6, correct? So 0 0 2 1s are 2 5s are, so 24 into 5, that is 120 hertz. And whatever we are finding, we should know the units of that also. Okay, what we are finding? Frequency. What is unit of frequency? Hertz. Next, this is the first sub question. Second sub question, that is nothing but time. How we can find the time period of a single wave? That is nothing but 1 by f. So it is 1 by 120, that will be equal to 8.3 into 10 power minus 3. And what we are finding? Time. What is the SI unit of time? That is seconds. That's it. Our next question, calculate the minimum distance in air required between the source of sound and the obstacle to hear an echo. Take the speed of sound in air is 350 meter per second. So it's a very simple question. All the data are given. So here we need to find the minimum distance. So distance we have to find, and this question is about echo. You have to be very careful whether it is related to echo or not. Well, once you find out, we have two different formulas for echo, one for normal formula. Without echo, normal distance, we have one more formula, correct? First we had to identify whether this question is related to echo or not. It is clearly mentioned that it is related to echo. So minimum distance, velocity is equal to 350 meter per second. And now So here we require time also, correct? When time is not given, you need to assume it as 0.1 second. Keep this in mind, because we know if it is less than 0.1 second, we are not going to get an echo. So the minimum time is 0.1 second. If it is not mentioned, we can assume it as 0.1 second. Now these are the data, and so what we need to find the minimum distance for echo. So see, if it is just a sound traveling so to some distance, okay, then velocity is equal to distance by time. But this question is about echo means going forward, hitting the surface and coming back. So two times we are traveling, right? The sound wave is traveling two times, so it covers two distance. That's why if it is related to echo, we have to use V is equal to 2D by T. If it is not related to echo, then the formula will be V is equal to D by T. There will be no 2 in that concept. So anyhow, this is related to echo. This is the formula. So D is equal to, if you send all these things that side, Vt by 2. So what is V? That is 350 into 0.1 divided by 2. If you solve this one, answer will be 17.5. What we are finding? Distance. What is the unit of distance? That is meter. That's it. Our next question: what should be the minimum distance between the source and the reflector in water so echo is heard distinctly? Okay, distinctly means properly. The speed of sound wave is 1400 meter per second. See, the speed of sound is increased because initial in the previous question it was about air. This is about water. We know so sound waves travel faster in water compared to air, correct? So here in this question we'll write the given data. V is equal to 1400 meter per second, and we are asking about minimum distance. For that, time should be 0. This is the minimum time required. Okay, more than 0.1 also we can hear an echo, 0.2, 0.13, all those things. But if it is less than 0.1, we will never hear an echo. Keep this in mind. So we need to find the distance, minimum distance. So this is this related to echo? Going forward and coming back. See, in the question they have mentioned the echo is heard distinctly. So this question is about echo, correct? Echo. So the formula will be V is equal to D by T, correct? No, it is 2D by T. If it is related to echo, it is 2D by T. So again we have to find the distance and everything, 2 and T that side. So D is equal to Vt by 2. Substitute the values. 1400 into 0.1 divided by 2. Okay, so this will be 70 meters. That's it. Our next question: a man standing 25 meters away from the ball produces a sound and receives the reflected sound. So the man is standing 25 meters away. So here this is question number 4. The distance is 25 meters, and calculate the time after which he receives a reflected sound if the speed of sound in air is 350 meter per second. So velocity is 350 meter per second. Will the man, okay, now we have to calculate the time here. Okay, second. Okay, second we'll focus on the second question later. Now first we'll find the time, because based on the time only we are going to answer this question. So here, so first we need to find the time. What is the original formula? Then we need to find T, right? So send this T that side, then it will be 2D by V. Substitute the values. 2 into 25 divided by 350. So answer will be, this is 50 by 350. So 0, 0, 5 ones are 5 sevens are 1 by 7 is nothing but 0.143 second. So listen, to hear an echo, the distance is not the only criteria. See, distance is minimum distance required is 25 meters, but it does not only depends upon the distance, it depends upon the mainly it depends upon the time also. So why it does not depend only on the distance? Because this type of reflector is also important. If it is a wall or a cliff, we can clearly hear an echo, but what if it is a sponge or thermocol? It observes the sound, it will not reflect it. So in those situations, distance will not be only the criteria, time is also one more criteria. So if distance is proper and we are getting an echo, and time is important, based on the time we can easily say whether we are going to get an echo or not. What is the minimum time? 0.1 second minimum. So that is a minimum time. More than that we can get an echo. Exactly at 0.1 also we can get an echo. Less than 0.1 we cannot get an echo. So here the time is 0. It is more than 0.1 second. So obviously we are going to get the echo. So answer for sub question B is echo. Yes. Why? Because the time taken for a reflection of sound is more than the minimum time required, that is 0.143. That's why we can clearly hear an echo. Our next question: a radar sends a signal to an aeroplane at a distance 300 km away with a speed of 3 into 10 power 8 meter per second. After how much time is the signal received back after reflecting from the aeroplane? So here it is about radars and aeroplanes. So here you need to focus only on the data. Okay, don't get confused with the situation. Okay, you need to understand the situation, but it's just a very simple thing. Okay, from the radar the signal is sent to the aeroplane and it is received back. Okay, now listen, first we'll write the given data. They have given the distance also, right? So this is question number 5. Distance is equal to 300 kilometer. Speed, that is nothing but velocity is given, that is 3 into 10 power 8 meter per second. We need to find the time. That's it, correct? So what is the formula? V is equal to 2d by t is there. We need to find the value of t, so substitute all these values, will get the answer, correct? Completely wrong. Why? Because check the units. Velocity meter per second, correct. Distance, it has to be in meters because the velocity is in meter per second. So convert all the first, before substituting into the values, convert all the values to their SI units. Okay, so this is nothing but 300 3 zeros, so this becomes meter. Now we can aramsai go for the value. So time, what is the original formula? V is equal to 2d by t. We require t, so this formula becomes 2d by v. Substitute all the values. 2 into, okay, divided by, what is the value of v? 3 into 10 power 8. 3 get cancels, correct? So here 1 2 3 4 5 zeros are there, here 8 zeros are there, so this becomes 2 divided by, okay, 10 power 3, correct? 2 divided by 10 power 3. So if you send this on upside, see, you can follow any method of calculation. Okay, final answer will be same, 2 into 10 power minus 3. What we are finding? Time, so the unit will be seconds. See, for every unit you are going to miss, okay, in the exam, or if you are writing a wrong unit in the exam, for everything 1 mark will be deducted. If the question is for 4 marks and you have to find, you have 4 sub questions, in all the 4 sub questions all the answers are correct but all the units are wrong, you are going to lose all the 4 marks. Units are very important, so focus more on unit and understand what you are finding. Our next question: a man standing 48 meters away from the wall fires a gun. Calculate the time after which an echo is heard. The speed of sound in air is 320 meter per second. Okay, listen, see, from now onwards we'll draw the diagram, okay, and then understand the question. Then it will be easy for us to understand the complicated questions. Now listen, so here first, this is question number 6. Okay, a man is standing 48 meters away from the wall. A man is standing 48 meters away from the wall. Okay, this is the wall and he is standing 48 meters away from the wall. Now listen, this distance, okay, has to be more than 17 meters, more than 17 meters, then only we'll hear an echo. Keep this in mind. The distance from the person, okay, he is starting the fire, this is nothing but the source, he is nothing but the source. So from the source to the reflector, okay, it has to be minimum 17 meters, minimum 17. If it is less than that, you will not hear an echo. Keep that in mind. So now anyhow it is more than 17 meters, we will definitely hear an echo. What they are asking for the time to calculate. So distance 48 meters, velocity they have given it as 320 meters per second. We need to calculate the time. Okay, now the same formula, v is equal to 2d by t. See, in this case, okay, we are definitely going to hear an echo, correct? So that's why it is 2d by t. In some cases, assume a person, I'll give this one as an example. Assume there are two walls, and here the distance is 12 meters, and here the distance is 21 meters. So whenever he fires a gun, the sound travels in both the direction, correct? So here also it will travel, here also it will travel. See, here it is clearly mentioned it is 12 meters, so no echo, no echo. So the formula we are going to use here for this condition, okay, v is equal to d by t, v is equal to d by t, because there is no echo. But when it comes to this condition, okay, this condition here, the minimum distance is 17, it is more than that, 21, that's why you are going to hear an echo. So which formula for you are going to use for this condition? It is v is equal to 2 by t. Now listen, so for anyhow this is a different question, okay, don't worry about it for now. This is the original question. Now we'll find the time is equal to 2d by v. So here 2 into distance, that is 48, divided by velocity. What is the velocity they have given? That is 320 meters. So the answer, final answer will be 0.3 seconds. See, the distance is more, minimum distance is 17, it is more, so minimum time required for an echo is 0.1 second. So it is more than 0.1 second, definitely we are going to hear an echo. Our next question, a ship on the surface of water sends a signal and receives it back from the submarine inside the water after 4 seconds. Okay, calculate the distance of submarine from the ship. Speed of sound in the water is 1450 meter per second. So first we'll write the given data. This is question number 7. We need to find the distance. So time is given as 4 seconds. After 4 seconds we are going to hear an echo. Okay, next velocity is given as 1450 meter per second. So which formula? This is the main formula. Always write the main formula so that you will not get confused in the exam. If you know the perfect formula, if you are finding the distance d is equal to vt by 2, then time, for time t is equal to 2d by v, if you know all those things, you can use it directly. But for the many students, they will get confused. That's why go with the primary formula. Here you will not get confused there. Okay, if you write it directly, if you make any mistakes, then the complete marks you are going to lose. That's why. Okay, what we need to find? D. So d is equal to vt by 2. Substitute the values. 1450 into 4 divided by 2. So the answer will be 2900 meters. So you can keep the answer, okay, in meters also. Okay, this is also fine. No need to convert into kilometers. Okay, if it is in kilometers, you have to convert into meters, because meter is the SI unit, correct? Now you can write it as 2.9 kilometer also, but here only you can, if you keep it, you will get the full marks. You can convert like this, because many students I have seen, even though they get the proper answer at the end, while converting, unnecessarily converting into another unit, they'll make a mistake, they'll lose marks. That's why. Okay, 1 mark will be deducted. That's why. So this is enough. Meters is SI unit. If you get the answer in kilometers also directly, that is also fine. Our next question, a pendulum has a frequency of 5 vibrations per second. See, a pendulum, this is a question number 8, right? We'll write the given data as it is. A pendulum has a frequency of 5 vibration per second, that is nothing but 5 hertz. 5 hertz. Okay. An observer start the pendulum and fires a gun simultaneously. A pendulum is started, at the same time a gun is fired. He hears an echo from the cliff after 8 vibrations. So 8 oscillations. Okay. So see, moving and coming back. This is one oscillation. That is nothing but one vibration. After 8 vibrations, he can hear an echo. Okay. Then if the velocity of the sound is 340 meter per second, find the distance. We need to find the distance. Now here, for our distance, we need to find velocity is given. What is the one more requirement? That is time. So using the frequency, we have to find the time. See, initially for 1 second it will vibrate. Okay, 5 times, correct, but he hears an echo after 8 vibration. Now listen, we know time is equal to 1 by frequency, correct? So frequency value is 1 by 5. But do you think after 5 vibration we heard an echo? No, correct. He hears an echo after 8 vibrations. So how to write like this? Initially you need to write the proper. For 1 second how many vibrations? That is 5 vibration. That you will write it in the denominator, because time and frequency are inversely proportional. So you write it in the denominator. After how many vibrations he had an echo? 8 vibrations. So extra vibrations are less than that. Okay, less than 5. More than 5 or less than 5 vibrations, you have to write it in the numerator. So here you are going to get the time value, that is 1.6 seconds. 1.6 seconds. Now we got the time. See, this understanding this one is very much important. If you have any doubts, just rewatch it, you will understand this one. Next, we got the time, velocity, how much they have given, that is 340 meter per second. 340 meter per second. I need to find the distance, correct, and this is clearly depends upon the echo process, correct. So here's an echo, correct. So we need, which formula we have to use? V is equal to 2d by t. We need to find the value of d. D is equal to vt by 2. Substitute all the values. 340, right? 340. 340 into time, it is 1.6 divided by 2. So final answer will be 272 meters. So what we are finding, the distance, the SI unit of distance is meters. There you have to be very careful. Our next question, a person standing between two vertical cliffs producing a sound, two successive echoes are heard after 4 seconds and 6 seconds. Calculate the distance between the cliffs. Speed of sound in air is 320 meter per second. See, for these kind of questions, diagram is not required, but if you can draw the diagram, it is easy for us to calculate the answer, because in the board exam, when it comes to echo related problems, most of the time they will give you diagrams. That's why writing the diagram, drawing the diagram is very much important. This is question number 9, correct. Now I'll draw the diagram. A person is standing between two cliffs, correct. One cliff, okay, and one more cliff. So a sound is produced by him. Two successive echoes are heard. One, okay, to hear an echo, it takes 4 seconds. To hear an echo from this one, okay, it takes 6 seconds. So between two cliffs he is standing, so he will hear two echoes, that too in two different sounds. Now we need to find the distance between the two cliffs. This is how you have to understand. Okay, draw the diagram. For every question, draw the diagram when it comes to these kind of questions. Now this distance we need to calculate. So here most of the questions will be based on two cliffs or one cliff only, but the way they are going to ask questions are different. Find the distance between the person and the first cliff, and find the distance between the person and the second cliff. All those things they'll ask, but in this question, so the distance between the cliffs, that means the complete distance, okay, from this point to this point we need to calculate. So complete distance means first we'll find this distance, then we'll find this distance, then we'll add together, we'll get the complete distance. That's it. So we know this is completely related to echo. So time t1 is equal to 4 seconds, t2 is equal to 6 seconds, and velocity is given as 320 meter per second. Now okay, we'll go for distance 1. Okay, for case 1, okay, case 1, or you can write it as just 1, anything is fine. Case 1, d1 we need to find. t1 is equal to 4 seconds. V for both the waves, it is 320 meter per second. So we need to find the distance, right? So we know the v is equal to 2d by t. So find the distance. Distance is equal to vt by 2. So here 320 into 4 divided by 2, that is, so what is the distance? Okay, this is d1, right? d1, so this is equal to 640 meters. That's it, 640 meters, d1. Okay, case 2. So here we need to find d2. t2 is 6 seconds. See, for every sub questions you don't have to write the given data. For your understanding, I'm writing it. V is equal to 320 meter per second. So d2 is equal to v. Okay, v here t1, right? It is t2 by 2. So it is 320 into 6 by 2. The answer will be 960 meters. 960 meters. So we require complete distance, correct? So this is d1 and this is d2. Complete distance means we need to add d1 plus d2. So distance between the two cliffs, you can write it like that. Distance between the two cliffs is equal to, so complete d is equal to d1 plus d2 is equal to 640 plus 960 is equal to 1600 meters. So finally the distance between the two cliffs is 1600 meters. Our next question, a person standing at a distance x in front of a cliff fires a gun. Okay, so this is question number 10, correct? So this question is very much important because we are going to get some equations and we are going to solve it. But if you understand the question properly, which I am going to teach you, then these kind of questions are very easy for you. Now listen, a person, there is a cliff, a person's A called A standing at a in front of a cliff at a distance of x. At a distance of x. Another person B is standing behind the person A. Another person B, okay, he is standing behind the person A at a distance of y. At a distance of y from the cliff. This is very much important. If they mention a person B standing behind the person A at a distance of y from person A, means only this distance is y. This distance is y. But here it is clearly mentioned that the distance y from the cliff. So from the cliff till the person B, it is distance y. It is distance y. This is very much important. So if you draw it properly, then you will get it correct answer. So if you take this as y, that is completely wrong because they have clearly mentioned the person B is standing behind A. Who is standing behind A? Okay, at a distance of y from the cliff. At a distance of y from the cliff. If they are mentioned at a distance of y from the person A, that means this distance would have been y. So this diagram, drawing the diagram is very much important. Now here's two sound. Okay, he is standing y from at a distance y from the cliff. Here's two sounds after 2 seconds and 3 seconds respectively. So he is going to hear two sounds. Okay, 2 seconds and 3 seconds respectively. Calculate x and y. Take the speed of sound, that is 320 meter per second. So here the speed is 320 meter per second. Now here we are going to use some common sense. Okay, so this person is going to fire. So understanding this concept is very much important. So this person is going to fire. So when the sound is when the sound is released from the gun, it will travel in this direction as well as in this direction, correct? It will travel this direction as well as this direction, and they have given two times. T1 is equal to 2 seconds and T2 is equal to 3 seconds. So whenever the sound is traveling from this person to this person directly, see here, this is direct, correct? Whenever the sound is traveling from the person A to person B, whenever he starts firing gun, to in both the directions sound will travel, in this direction as well as this direction, correct? So in this direction, do you think this is related to echo? No, right? This is not related to echo because the sound is traveling from this person to this person directly, so it is not related to echo. But out of these two, which is direct, okay, which is direct time, which is related to this movement, which time is related to this movement, whether this time or this time, obviously it is T1 only. Why? Because to travel directly it requires less time. So here we know that sound will travel also in this direction, and it travels and goes back, so it requires more time. So for echo related concept, time too we have to use direct concept. The sound is traveling directly from person A to person B, so the from here to here, okay, it is a direct, no echo related, so time is 2 seconds. Time is 2 seconds. We got to know to find this value, okay, to find distance from this person to this person, time is 2. So what is the distance now? The speed is given, so what is the distance? We cannot just take d, correct, because we have two different distances. See, from here to here we need to find the distance. The complete distance is y, only few is x. So from the complete, if we remove few, the remaining thing will be the distance, correct? So from the complete distance, if we remove x, then the remaining value will be the distance from A to B. Why we have to find the distance from A to B? Because sound is traveling from A to B, that's why we need to find the distance. For this time, that is 2 seconds, okay, velocity is given, velocity is same for both the cases. For time we got to know that is 2 seconds, velocity is 320 meter per second. So we are talking from A to B, right? A to B, so the distance should also be A to B. How to find the distance between A and B? We got y, that is from B to the cliff, the complete distance, and we have some small distance that is from A to x. If we remove, okay, it's very simple. If there are two children, the father gives 100 rupees for the first one and tell him to take 40 rupees and give it to the remaining amount to the other child, correct? So in the same way, the complete amount is 100 rupees, you take 40 rupees, the remaining you give it to the other person. Remaining, how will do that? By subtracting, that's it. So that is for first case, okay. Case 1, okay, no echo. No echo when the sound travels from okay, A to B. Here time is 2 seconds and velocity is 320 meter per second, and the distance is, okay, you can take it as just d, okay, you can take it as d1, anything is fine, and there is no rule that this has to be t1 and that has to be t2, anything you can take. The final answer will be proper. So d1 is equal to y minus x, complete distance minus x. So this is very much important, and we know this is not related to echo, so we should not use v is equal to 2d by t, because the sound is traveling directly, right? No echo, so we should not use v is equal to 2d by t. We should not use this formula. This 2 will come only when there is an echo. We know there is no echo, so we have to remove this 2. So we need to find this distance, right? So d is equal to v into t. What is the distance? That is d, this is d1, right? Y minus x is equal to v, that is 320 into time, that is 2. So this will be 640 meters. Y minus x is equal to 640 meters. This is an equation, right? So write it as equation 1. Now we'll talk about case 2. So here what is the time? That is t2, 3 seconds, then velocity is equal to 320 meter per second, and distance. So this is very much important. So distance, see, initially we have taken d1 for first case, so we'll take d2 for second case. So here what is the distance traveled? We know sound will travel in both the direction towards right, that is the first case. Now sound is traveling towards the left. See, it goes here, it's the cliff or mountain and comes back. So how many distances? 1 and 2, correct? Both the directions we are including. So d2 is equal to y plus x or x plus y, anything is fine. See, it will travel here, hit the cliffs and goes back. That's why this is x and goes back, right, plus the complete distance y. This is what we are taking d2 as. Now what is the formula we have to use? So this is properly related to echo, correct? So which formula we have to use? V is equal to 2d by t, correct? No, completely wrong. Why? Because actually we have to use V is equal to, see, V is equal to 2d by t formula only we have to use. But even though it is related to echo, we are not going to use this 2. Why? Because why we are using 2? Because sound will travel 2 distances, correct? Both the distances we have already taken in the this one numericals. If the distance values are given directly, or if you are finding the distance value, okay, if this x and y are not given, okay, if x and y like this are not given, then you have to go for v is equal to 2d by 2 to find the distance. But here hence we are using, see, both the distances we are using here, right? d2 is equal to y plus x, both the distance we have already added. That's why instead of 2d we are just taking d, okay, because d, this complete d as both the distances. So this will be okay. And now we will substitute the values. d2 is equal to, first find the value for this one formula, v into t2. d2, what is d2? Y plus x is equal to, what is v? 320 into time, that is 3. This will be 960 meters. So y plus x is equal to 960 meters. Okay, this is our equation 2. Next, we have 2 equations, right? Now we have to solve through simultaneous equation. So first equation, y minus x is equal to 640, then y plus x is equal to 960. So x and x will get cancelled, this will be 2y, we have to add these two, so this will be 1600, y is equal to 800 meters, correct? If you send this to that side, so 1600 divided by 2, that is nothing but 800. So once we get the value of y, it is easy to get the value of x. You can substitute y value in any one of the equation, okay, first equation or second equation. So here we'll go for second equation. You can choose any equation. Now what is the second equation? X plus y is equal to 960, correct? Now we want x value, substitute, first substitute y value here, 800 plus x is equal to 960. Now we want x and is 800 that side, so x is equal to 960 minus 800, so x is equal to 160 meters. That's it. Okay, so first understand the concept here. Initially the sound traveled from A to B directly, correct? So no echo. When there is no echo, which is the formula we have to use? D by T, V is equal to D by T. But taking this D1 and D2 value in both the cases is very much important. In D1 we understood properly, correct? So why we are using V is equal to D by T? Because it is not related to echo. When it comes to second case, here also we did not use 2d by t, okay, v is equal to 2d by t, even though it is related to echo. Because why we are using 2 extra 2d by t? Because sound will travel 2 distances, but here we have already taken, see, so, in second case sound will travel from A to cliff, that is x, okay, it has traveled 1 distance, then plus it has traveled y, so we have taken x plus y, both the distance we have taken already here, that's why we are not using 2 here. So substitute the values, get the equation and go for simultaneous equation, we'll get the complete answer. Our next question, on sending an ultrasonic wave from a ship towards the bottom of the sea, The time interval between the sending the wave and receiving it back found to be 1.5 seconds. So this is the complete time, right? You need to be aware of it. The complete time going and coming, sending and receiving. Sometimes sending and receiving also separate times will be given. You have to add it so that it will become the complete time. So this is question number 11. Time is equal to 1.5 seconds. If the velocity of the wave in sea water is 1400 meters, so that is 1400 meter per second, find the depth of the sea. That is nothing but the distance. It's a very simple formula. This is related to echo because it is going, okay, we are sending and receiving back, that is an echo. So velocity is equal to 2d by t, d is equal to vt by 2. Substitute the values, make sure all of them are in proper SI units. 1400 into 1.5 divided by 2, so this will be nothing but 1050 meters or 1.05 kilometers. That's it. Our last question, figure below shows the distance displacement graph of two waves A and B. Compare their amplitudes and wavelength of the two waves. See, if you have understood the meaning of amplitude and wavelength, this is a very easy question for you. So first one, we have to compare between, okay, amplitudes. Okay, now listen. So what do you mean by amplitude? The maximum displacement of a wave. This wave or this wave from the mean position. From the mean position, from this mean position, okay, or this line. Mean position is this line. From this line, what is the maximum height? Okay, is nothing but the displacement. So which has more height, wave A or wave B? See, wave A has 10, correct? Wave B has 5. So which has more? A, correct? A has more amplitude. So we need to compare the amplitudes. That means, so A, okay, A is to B is equal to how much? 10 is to 5, correct? So this is the amplitude. Final answer, wrong. Amplitude, whenever you are writing any answers, okay, in the form of ratios, okay, you have to follow few things. One, the final answer should not be in decimal form. This is not in decimal form, okay. The final answer should not be in fractional form. So it is not in fractional form, okay. But the final answer should be simplified. Both the numbers should not be divisible by any number, okay. Then it is the final answer. Now both the numbers are divisible by a number, right? 5 ones are 5 twos are, correct? So it is 2 is to 1. That's it. Okay, this is how you need to understand. Next, they are talking about wavelength. Okay, wavelength symbol is lambda, correct? So wavelength ratio we have to write. So A is to B we have to write. Okay, you can write it as wavelength also here instead of symbol. Now see the wavelength. So here it is 2, 4 and 6, 8, 10, 12, 14 and this is 16. See, what is wavelength? The length of one wave. See, only one wave, the length of only one wave. We'll talk about A first. This is the complete one wave, correct? The length of one wave from 0 to 8, correct? From 0 to 8, that is A. Now we'll talk about B. The length of one wave, right? The B wave starts from here, that is 0. It ends here. See, this is not one wave. This complete upper part and the below part is togetherly considered as one wave. So from 0 it has covered till 16. So do you think this is our final answer? No, it is divisible by same numbers, right? 8 ones are 8 twos are, so it is 1 is to 2. Okay, if you can solve divide it by 2 also, 2 fours are 2 8s are, again 4 is to 8 divisible by other number. That's why, okay, the final answer should not be divisible by any number. See, 1 is to 2, both the numbers are not divisible by any number. So this is our final answer. Now we have completed all the numericals from this part A of sound chapter, that is reflection of sound and echoes. So after this one we have part B and part C also. Watch all the videos, be perfect, and you will understand how to get the complete marks without touching the textbook. So after solving the concept video where I am going to teach and theory solution where we are going to provide the complete key answers, not the answers. We can get all the answers whatever we are learning here in the Google also. Then why we have to watch the video? Because here I am explaining. Okay, explaining, will understand things. Then we have solved all the numericals, concept, theory and numericals. After this one, okay, we will get only 80 to 90% of the knowledge. Remaining knowledge you will get it from previous year papers. Okay, then logical and application, all these things we are going to solve, and all these things will be chapter wise. From the chapter sound, what are the previous year questions they have asked? If I just give you the previous year paper, you just see and leave it. But only from the sound chapter, if I teach you all the previous year questions, then you will understand the complete knowledge. Correct, you will get the complete knowledge of sound. After that we are going to solve logical and the application questions, that is also chapter wise. Only from the chapter sound, what are the logical and the application questions, all these things are in the description box. So watch it and learn it completely, get the complete knowledge and get 80 on 80 without touching the textbook. Thank you.